everyone, welcome to my YouTube channel. Today I'm going to discuss about raster scan display. Okay, so let's start with this. If you are not subscribed to my YouTube channel, then please subscribe. And now let's start with it. This is the most common method of drawing image on the CRT screen. CRT screen, in the old days you have seen the desktop computers in which there is a big bump beside the monitor. Okay, so that are actually CRT monitor. So how it's work actually I'm going to show you. Here you can see this in this picture. It's work line by line. Okay, so let me just discuss more. In this method, horizontal and vertical deflection signals are generated to move the beam all over the screen in a pattern. That is, the electron beam is swept across the screen one row at a time from top to bottom. Here you can see this, that it actually clearly says that it's run from first line one by one to the bottom. Okay, and after that, here the beam is swept back and forth from left to right across the screen. When the beam is moved from left to right, it is on. The beam is off when it moves from right to left, and it's called as horizontal retrace and is shown by dotted lines. Here you can see this. These lines are moved when this beam is on, and when these back from right to left it moves, it the beam is actually off, and it's denoted with the dotted line. When the beam reaches the bottom of the screen, it is turned off and is rapidly retraced back to the top to start again. This is called the vertical retrace. In the raster scan display, the screen image is maintained by repeating scanning at the same time. Here you can see this. It exactly says that by repeating the beams, it shows the image. And after that, the process is shown as refreshing of a screen. Okay, so it's just refreshing, keep refreshing the screen so that image reside on the screen. Okay, so now we are going to talk about the internal operation of raster scan display. So here the internal implementation, and now we discuss this. Picture definition is stored in a memory area called refresh buffer or frame buffer. Here you can see this, it's a frame buffer. Here the picture definition is stored, and or frame buffer for which a find area of the system memory is kept reserved. This memory is reserved to store the picture definition. The frame buffer holds the set of intensity values for all the screen points. Okay, so it says that frame buffer, this frame buffer holds that which which screen point will have dark color or which screen points have light color. These data are stored in this frame buffer. Okay, so stored intensity values are then retrieved from the refresh buffer and display on the screen one row at a time. Here you can see this, it's clearly saying that stored intensity in the frame buffer will be retrieved from the refresh buffer and displayed on the screen one row at a time. One row at a time. After that, showing the one row, after that it shows second, and in the same way for till the last. Okay, so we have to discuss more points. So video controller has direct access to memory location. Here you can see this, the video controller, this video controller has direct access to the memory locations in the frame buffer. Okay, it is responsible to retrieve data from the frame buffer. Video controller retrieve data from this frame buffer and passes it to the display devices. Here you can see this, it retrieves data from here and it shows on the display. Now after that, frame buffer maps the screen into characteristic coordinates. Generally the screen coordinates are taken as positive xy plane, hence the screen is continuous refreshed by scanning from maximum value of y coordinate down to y0. So that's it for the today's video. Thanks for watching. Please subscribe my YouTube channel and hit the bell icon, and if you want to watch more videos then just go to my channel and check out my playlist. Thanks.